Function composition. This video explains composition of functions and domain of composite functions. Composition of functions f and g. F circle g defined over x is the composition of functions f and g defined over x and is written as an equation f circle g defined over x is equal to f of g of x. We can visualize like this. X is the input and is going to a function g, and we apply the function g to x and we get g of x as an output. Now we use this g of x as an input to another function f, and we apply that function to g of x, so we get f of g of x as an output. So how to find f of g of x? Replace, substitute the inner function g of x in the outer function f of x for every x in f of x. Composition of functions g and f. G circle f over x is the composition of functions g and f defined over x and is written as g circle f over x equals to g of f of x. Visualize, x is the input to function f and we apply the function f to x, we get f of x as an output. Then we use this output and we input this f of x to another function g and apply this g to f of x, and we get g of f of x as an output. So how to find g circle f of x? So we replace or substitute the inner function f of x in the outer function g of x for every x in g of x. Are composition of function f and g and the composition of g of f the same? No. Composition f of g defined over x is not the same as the composition of g and f defined over x. That is, the function composition is not commutative. Composition of function f and f. Now we define f circle f over x is the composition of the functions of f and f defined over x, and we write this as an equation f circle f over x is f of x. So imagine here x is the input to the function f and we apply the function f to x and we get f of x. Now we take this f of x and input to the same function f and apply the function f to f of x and we get f of x as an output. So to find the composition of f and f defined over x, we substitute f of x into f of x for every x in x. Composition of functions g and g. G circle g over x is the composition of functions g and g defined over x and is written as an equation g circle g over x is g of x. So visualize, input x is the input and it goes to function g and apply the function g to x, we get g of x. Then we take this g of x and input to the same function g and apply g to g of x to get g of x as an output. So to find the composition of g and g defined over x, we have to substitute g of x into g of x for every x in g of x. Domain of composition of two functions. So domain of composition of f and g defined over x is a set of the real numbers x in the domain of the inner function g such that g of x is in the domain of f. To find the domain of the composite function f circle g, we can do the following. First we find the domain of the composite function f circle g. Then we exclude any restriction in the domain of the inner function g from the domain of the composite function f and g. And the result will be the domain of f composite function f and g. So here is example number 1. We are given f of x equals to 5x plus 6 and g of x equal to 1 over x minus 3. So we're going to find the composition of f and g, and then we write the domain in the interval notation. So let's start with this one. The definition of the composite function f circle g defined over x is f of g of x. So g of x is the inner function and f is the outer function. So we're going to replace the g of x equals to whatever g of x is. So g of x is 1 over x minus 3. So we're going to replace this g of x with 1 over x minus 3. So we have now f of 1 over x minus 3. So to find this one, we're going to substitute 1 over x minus 3 in the f of x where the x is. So this will become 5, replace the x with 1 over x minus 3 and plus 6. Now we just simplify. So this becomes 5 over x minus 3 plus 6. And so this is a fraction, this is a whole number. So LCD is x minus 3. So we're going to convert 6 into a fraction with the same denominator as x minus 3. And how are we going to do that? We multiply 6 with x minus 3 and divide by x minus 3. And now we simplify. So let's say 5 plus 6 times x minus 6 times 3, 18. So if we further simplify, we get 5 minus 18 is minus 13 and 6x. So we have 6x minus 13 over x minus 3. So we have found the composition of f and g as 6x minus 13 over 13. And we already know the inner function is g of x is 1 over x minus 3. So it looks like they look the same. Both have the same restrictions. X cannot be 3. So the domain of this would be all real numbers except 3. And we write this in interval notation, minus infinity to 3 union 3 to infinity. So it is example 2. F of x is 5x plus 6, g of x is x minus 3. And we have to find the composition of g and f. So we write composition of g and f by definition is g of f of x. So here f of x is 5x plus 6. So we're going to replace first f of x with 5x plus 6. So now we're going to find g of 5x plus 6. So to do that one, we substitute 5x plus 6 in whatever g of x is equal to. G of x equal to x minus 3. So we're going to replace this x with 5x plus 6. And we write here. So we have 5x plus 6 minus 3. Now we remove the parentheses and simplify. So we get 5x plus 6 minus 3 is 3. So the composition of g and f is 5x plus 3. Now the domain of the composition of g and f would be all real numbers. Or you can say minus infinity infinity because 5x plus 6 is a polynomial, and we know the domain of polynomial function is all real numbers. Now f, which is the inner function, we want to check if that's had any restriction. So f is just a polynomial, it has no restriction. So therefore the domain of g and f stays what we found, minus infinity to infinity. Okay, here is an example 3. We're going to find the composition of g and g of the function f of x equal 5x plus 6 and g of x equal to x minus 3. So by definition, g composition with g is equal to g of x. So first we're going to replace g of x with x minus 3. So now we're going to find g of x minus 3 using the same function. All I have to do is where the x is, we substitute x minus 3. So this changes to x minus 3 and minus 3 comes down. So the parentheses, you have x and minus 3 becomes minus 6. So the answer is composition of G with G is x minus 6. Here is another example. We are given f of x equal to x squared and g of x is x minus 1. And we have to find the composition of f and g. And we write the domain in the interval notation. By definition, f composition g defined over x is just f of g of x. Now g of x is the inner function, so first we're going to replace g of x here and bring the f down. So g of x changes to x minus 1. So we have f of x minus 1. Now we're going to find f of x minus 1 by replacing or substituting x minus 1 with the axis in the function x squared. So we're going to change x to x minus 1 and keep the power 2. So we have x minus 1 squared. And we just multiply. So you multiply, you should get x squared minus 2x plus 1. So now we're going to write the domain of this one, f, composition f and g. And so it be just, they're all basically polynomials. So it's the same as the domain of g of x, which is minus infinity to infinity. So here is another example. So f of x is x squared and g of x is x minus 1. And we have to find the composition of g and f. So by definition, g and f defined over x is g of f of x. So now we replace the f of x with this whatever f of x equals to. Here f of x equals to x squared. So we're going to change this to x squared. Now we have a g of x. So we're going to find g of x squared. Now we're going to substitute x squared with the x's here. And so this x changes to x squared right here and then bring minus 1. And that is, we found the composition of g and f. So here is another example. F of x is x squared and g of x is x minus 1. And now we have to find the composition of g and g. So by definition, the composition of g and g is simply g of x. So first replace the g of x, inner function. Always replace inner function first. So g of x changes to x minus 1 because g of x equal to x minus 1. Now we have to find the g of x minus 1. So we're going to take x minus 1, put where the x is. So we bring it here and bring the minus 1 down. Now we simplify, so we have x minus 2. So this becomes x minus 2. Example 7. F of x equal to x squared and g of x is x minus 1. Now we have to find the composition of f and f. So by definition, composition of f and f defined over x is f of x. So inner function, first we replace f of x. F of x is x squared. So replace this with x squared and bring this f down. So now we have f of x squared. So now to find this one, we take this x squared and substitute where the x is here. And so they become x squared, x changes to, but keep the power. So now we have a x squared squared. So we multiply the power. So this becomes x to the 4. So the answer is x to the 4. Example 8. We are given f of x equal to square root of x plus 4. And we have g of x equal to x cubed. We're going to find g composition of g and f. I'm going to write its domain in the internal notation. By definition, the composition of g and f defined over x is simply g of f of x. So the inner function is f of x. So we're going to replace f of x with equal to whatever is this equal to. So this is the square root of x plus 4. So we have to find the g of the square root of x plus 4. Okay, well now we need what is g of x? Well, g of x is equal to x cubed. So we're going to replace this x, change this x to square root of x plus 4. So this becomes cube of square root of x plus 4. Now square root means x plus 4 to the power 1 half. So 1 half times 3 would be 3 half. So the answer is x plus 4 to the power 3 halves. Now let's find the domain of g, what we found. Well, this is like a kind of square root function. So the domain of this would be simply x plus 4 should be bigger than or equal to 0. Now I move the 4 to the right, so it becomes x bigger than or equal to negative 4. So the domain of this composition of g and f is in interval notation minus 4 to infinity. And g of x has no restriction, so therefore this is the final answer. All right, we're now going to use the graphs of f and g to evaluate the composition of g over 4. Well, first we need to write what this means. By definition, f composition with g defined over 4 is f of g of 4. So the inner function is 4. If 4 is the input to g function. So first we're going to find g of 4 from the g of x. So we locate the 4, I think 4 is here. And we go up and looks like a 2. So we change g of 4 equal with 2. Now if we have f of 2, so now we find f of 2. And looks like this is 2 here, and here the graph touches. So f of 2 equal to 0. So the answer is 0. Example 10. Now we're going to find the composition of g and f defined over 4. So we start with g and f defined over 4. That's g of f of 4. So now we're going to find first the f of 4. So let's see, f of 4 is this one, f of 4. So we go up and it's equal to 6. So f of 4 is 6. So this becomes g of 6 now. Now we're going to find the g of 6. And so that's 6. And here the graph basically crosses x-axis. So the g of 6 is 0. So the answer is 0.